Hello, awesome CC3 students, and welcome back. In this video, we are going to be going over the keys and steps for simplifying complex integer expressions. So these are expressions that have multiple terms. You might have quotients mixed with products, mixed with sums, mixed with differences. So if you remember, our keys are, number one, maintain the structure. So if the structure of the expression is a sum, you want to keep that structure until the very last step, when you will then combine those terms together. Similarly, if the structure of the expression is a product, keep it as a product until that very last step when you multiply those factors together. The second key here is always try to identify the terms in the expression. Remember, terms are separated by addition signs and subtraction signs outside of parentheses or groups. So if you can identify the terms in the expression, that will help you maintain the structure, because if there are three terms, your expression should stay three terms until your very last step. And then finally, and most importantly, keep your work organized and readable. So while you're working, make sure that we can follow every single step, working from top to bottom, or if you have to move over, making sure that we can actually see your process of thinking. So in this video, we're going to go through some examples from a worksheet practice and following these three keys for simplifying. Okay, so here's our worksheet practice on simplifying complex integer expressions. So again, maintaining the keys, we're just going to go through and do a couple of these examples. So the first key is maintain the structure, identify the terms, and keep your work organized. So first of all, if I'm going to identify the terms in the first expression, I notice that I see a subtraction sign outside of parentheses and another subtraction sign outside of parentheses, which leads me to understand that there are three terms here, 1, 2, and 3. Now in this first one, you'll notice that all three terms are already simplified values, meaning this -4, I can't do anything with it. Same with the -5 and same with the 2. So in this case, maintaining the structure isn't really necessary because these are all what we would call simplified terms. So now we're just going to go in and simplify from left to right. Now, I see a couple of equivalences here. For example, subtracting a negative is equivalent to adding. So some of you might be able to keep it like that. Others might have to rewrite this as -4 plus 5 and then -2. Again, notice how my work is staying organized. My terms are directly underneath each other. Now going from left to right, -4 plus 5, that would be moving from -4 to the right 5, I'd end up at 1. Bring down your -2. Again, notice how my work is staying organized. And 1 minus 2, I end up at -1. So again, for this one, I maintain the structure until the very end, keeping my work organized that you could follow. Okay, moving over here to number 2, I do see a subtraction symbol outside of parentheses, which means I have 1 and 2 terms. The first term is already simplified, so I know there's nothing I can do with it, but this second term is what we would call a group. So before I can subtract, I must first simplify that group. So the first term is already simplified, it's going, and I'm maintaining the structure, it's still a difference, still subtraction. What is 2 plus 6? 2 plus 6 is 8. So now I still have 2 terms. I still have 1 and 2, but now these 2 terms are simplified, meaning I can go in and combine from left to right, which in this case, because it only has 2 terms, that just means doing the math of -6 minus 8. So let me think about this. This might be a little bit tougher. If I'm going from -6 and I'm going back 8, 1, 2, 3, 4, 5, 6, 7, 8, I'm going further away from 0. I'm going to end up at -14. All right. Number 3 is very similar to number 2, so we'll skip that one for now. Let's take a look at number 4. I don't see any addition or subtraction outside of a group. This one is technically outside of parentheses, but it's part of this numerator, which means it's technically inside of a group that makes up the numerator. So here, this would just be considered a quotient with a single term, but the numerator is a group that isn't simplified. So my first step is going to be to simplify the numerator. So this is still going to stay a quotient. I'm maintaining that structure. All I'm doing is the 9 minus 3. 9 minus 3 is 6. Now that this is a quotient with a simplified numerator and denominator, I can go ahead and divide. 6 divided by negative 2 is negative 3. I always like to do quotients horizontally rather than vertically because then I can keep track of what's in my numerator and what's in my denominator. The same thing goes for this one at number 6. 4 plus 2 would have to be simplified before 3 minus 5. Now, number 5 is a really tough one, and it doesn't look that tough, but it really actually is tough. So the deal with number 5 is that most of us will think, oh, this is pretty simple. I just do 1 plus 6 and 3 minus 8 and get 7 times negative 5, and boom, I'm done with negative 35. Awesome, that was easy, moving on. No, no, no. If you're maintaining the structure of this expression, you have to pay attention here. This expression has addition outside of parentheses, meaning it has 2 terms. This is your first term, and this entire thing here is your second term, meaning this is a sum of 2 terms. My last step will be to add. So something that some students like to do, or that we like to do, is I like to bring down this addition sign because I know that it's going to take me 2 steps to simplify this term. One will be subtracting and one will be multiplying. So that I don't get tempted to add too soon, I'm going to account for both of those steps so that I don't get the temptation to add 1 and 6. Because 1 and 6, those aren't terms by themselves. 1 is by itself, but 6 is part of the second term. So here we go. When we're simplifying the second term, we start with 3 minus 8, which is negative 5. So this product, maintaining the structure of that product, that becomes 6 times negative 5. Again, I'm not going to add this 1 and 6 too soon until this second term is fully simplified. 6 times negative 5 is negative 30. Now that both terms are fully simplified, I can combine from left to right. I know that adding a negative is equivalent to subtraction, so it might be that I want to change that to subtracting 30 either way. Notice that I ran out of room, so I like to use an arrow to show that my work continues. 1 minus 30 is negative 29. So again, if you look at our keys, we are maintaining the structure of the expression throughout. If it's a difference, it's maintaining as a difference. If it's a quotient, maintaining as a quotient, a sum as a sum. We are identifying terms, and we're looking for addition and subtraction outside of parentheses. In a quotient, you're not really identifying terms as much. You're identifying your numerator and your denominator. And we're keeping our work easy to read and organize. So I'm going to go ahead and move down to a couple tougher examples here, just where we get a little more complex. So for this one, let's look at number 8 here. For number 8, we have, it looks like there's no addition or subtraction outside of parentheses. So this is a single term, and this term is a product. Now, products are made up of factors. So this first group here represents one of the factors, and this second group here represents the other factor. So as we go to simplify this, we're just going to simplify both of these groups at once, maintaining the structure that this is a product. Because it's a product, that means we're going to multiply last. So negative 6 plus 5, if I draw out a number line here, here's negative 6, and I'm adding 5, 1, 2, 3, 4, 5, I would end up at negative 1. And over here, negative 6 minus 4, I'm going backwards, 1, 2, 3, 4, and I would end up at negative 10. So this is equivalent to negative 1 times negative 10. Again, it's still a product. Now that both factors are simplified, I can go ahead and multiply, and then negative 1 times the negative 10 is a positive 10. All right, we're going to do a couple more tough examples together, and then I'll wrap up this video. Looking over here, number 9 is also a bit of a tough example. Notice that there is one addition sign outside of parentheses, which means this expression has 2 terms, and it is a sum. Because it is a sum, that means that we'll be adding last. Now, it's only going to take 1 step to simplify this first term, but this second term has 2 steps. First, I subtract, then I multiply. So I'm going to set up 2 sums so that I don't get tempted to add too soon. 18 divided by negative 3 is negative 6, And now that's already simplified, but over here, this is gonna take 2 steps. So I'm just gonna bring down that -6 again. I don't wanna be tempted to add it to that 4. Over here, we have to subtract first because this is a group in the product and you have to simplify both factors. So we're gonna bring down the 4 and 3 minus 6 is -3. I don't want to be tempted to add those too soon. That's why I had the -6 there. 4 times -3 is -12. Now I've maintained the structure of a sum all the way through. Now I have 2 terms that are simplified, so I can go ahead and combine them. Adding a negative is equivalent to subtraction. So if you want to rewrite this as -6 minus 12, you can. If I think about a number line, here I am at -6, I'm moving back 12, 5, 6, 7, 8, 9, 10, 11, 12, and I end up at -18. Again, identified number of terms first, maintain the structure of a sum all the way through until the very last step. Okay, we're gonna end off here with a challenging problem, one of the most challenging problems on this entire worksheet. We're gonna go ahead and do, which one should we do? I think we should do one that at least has a quotient. Let's go ahead and do number 13. And this will be the last one that we do. Okay, number 13, step 1, we're identifying how many terms in the structure. So we have subtraction here and addition here, which means we have 1, 2, 3 terms in this. So of the 3 terms, it looks like the first term will take 1 step to simplify. The second term is already simplified, and that third term is going to take 2 steps to simplify. So I'm going to set up to keep myself from adding or subtracting too soon. I'm going to set up 2 difference in sum signs because I know this is going to take me 2 steps. So here we go. 3 divided by 3 is 1. 2 is already simplified. And over here, -6 minus 1 is -7. Now again, this term is not yet simplified. So I'm not doing anything until all my terms are simplified. I don't want to be tempted to add too soon. 2 times -7 is -14. Now I still have 3 terms, term 1, term 2, and term 3. The difference here is now all 3 terms are fully simplified terms, which means I can go in and combine from left to right. And yes, it does matter. You do want to always go from left to right when your terms are simplified. So we're going to start with 1 minus 2. 1 minus 2 is -1. Bring down our plus -14. Again, adding a negative is equivalent to subtraction. So if you wanted to rewrite this as -1 minus 14, you could. So thinking about a number line, here's -1, I'm going back 14, blah, 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 however many that is, and I would end up at -15. So again, even though the expression is super complex, we maintained the structure of a sum and a difference. Look at this. It's still a difference and a sum, a difference and a sum until we ended up combining. We kept our work organized. You can see my steps all the way through here. And we identified the number of terms. And this will help you avoid making silly mistakes. That's it for today's video. Again, maintaining structure, identifying number of terms, and keeping your work organized are all important keys. And then I always suggest using a resource like a number line or a multiplication chart if you struggle with those integer operations. All right, I'll see you next time. Have fun simplifying expressions.